class, welcome all. Today that we are going to discuss the new consideration, that is your cantilever beam. Suppose you have a cantilever beam at a point moment at free end, right? What we are going to see, a cantilever beam at a point moment at free end, right? At free. This is the case that we are going to discuss. Let's see this. So we apply a moment at the end. So this is defined as the y-axis, and this is defined as the x-axis, right? And this is the magnitude of moment m. Let's take x. आपने x section लिया है along x-axis, and the distance from the point is mx, right? So अगर इस condition में if we want to find the moment at x section, then we can define it as that is mx is nothing but of minus m, right? Since this is anti-clockwise left hand side, so we are considering it as a minus. Based on this, we know this equation, that is differential equations of deflection curve, that is dy di d square y upon dx square is equals to mx, which is also to be written as minus m. Let's say integrate it. Once we integrate, we will get ei dy by dx is equals to minus mx plus c1, right? So this is the first condition that we are going to see, right? Just let me know, at x equals to L, at x equals to L, there should not be any slope that is defined as this one. So dy by dx is defined as 0, right? Once we put the value of dy by dx is equals to 0, we obtain this equation, that is this one. 0 is equals to minus ml plus c1. It means what? The value of c1 is defined as ml, and you get an equation, right? ei dy by dx is equals to minus mx plus ml, right? So this is the first equation we obtained from the differential equation of deflection curve, right? This is the first slope equation, you can say, right? So let's understand what is the maximum value of the slope. So the maximum value of slope is occur at x equals to 0. So at x equals to 0, you will get theta max, that is the maximum slope, which is defined as when you put the x equals to 0 is equal to in this equation, ये आपकी value 0 हो जाएगी, ml हो जाएगी, और ei into theta max हो जाएगा. So this can be written as ei theta max is equals to ml. It means what? The value, that is the maximum slope, is defined as ml upon ei. So this is one thing that we need to remember, right? So based on this double integration method, let's integrate further of equation number 1. तो हमें क्या मिलेगा? We will get, see these conditions. आपने integrate किया तो you will get ei into y, right? That is minus mx square y2 plus mlx plus c2, right? So this is the equation we have obtained. So put Just tell me one thing. At x equals to 0, we all know that x equals to 0, there should not be any, right? So when we say that x equals to 0 is no movement, can we put this values at x equals to L, at x equals to L, we do not have any deflection, right? So deflection at this point is 0. So simply at x equals to L you will get y की वैल्यू 0 है, तो यहाँ पे इक्वेशन क्या चेंज हो जाएगी, ये हो जाएगी 0, दिस इज 0 इक्वल्स टू माइनस ml स्क्वायर बाय 2 प्लस ml स्क्वायर प्लस c2। अब यहाँ पे ml स्क्वायर है, ये ml स्क्वायर बाई 2 यानी कि हाफ ऑफ ml स्क्वायर हो जाएगा, तो ये प्लस ml स्क्वायर बाई 2 हो जाएगा, तो c2 की वैल्यू जाएगी माइनस ml स्क्वायर बाई 2। यस, so the value of c2 is defined as minus ml square by 2. So if we put the value of ml square by 2 in this equation, what we will get? We will get the second equation, which is defined as ei into y is equals to minus mx square by 2 plus mlx plus, sorry, minus ml square by 2. So now this is your deflection equation. अब इस इक्वेशन को अगर आप समझें कि पुट एनी वैल्यू ऑफ एक्स, अगर आपको किसी भी इंटरमीडिएट पॉइंट पे एक्स की वैल्यू पे आपको डिफ्लेक्शन पता करना है, यू जस्ट द वैल्यू, यू पुट द वैल्यू ऑफ एक्स इन एनी ऑफ द कंडीशन, यू विल गेट द वैल्यू, राइट? अब आपको क्या मैक्सिमम डिफ्लेक्शन चाहिए, तो मैक्सिमम डिफ्लेक्शन ऑलवेज अकर एट द व्हेन यू पुट द वैल्यू x इक्वल्स टू 0. So at x equals to 0, we can say, we'll write in a different color, at x equals to 0 you will get delta max, which is known as a maximum deflection. So this is the value of maximum deflection. Put the value of x equals to 0, यहाँ पे तो ये 0 आएगा, ये वैल्यू 0 हो जाएगी, ये वैल्यूज क्या हो जाएगी माइनस ml स्क्वायर बाई 2, राइट? which is also defined as delta max is equals to ml square by 2 e. So this is the deflection at the when the value of at x equals to 0. So let's take another example of simply supported beam. Simply supported beam with mid point load, right? Simply supported beam with midpoint load. So let's see. This is a case of simply supported beam, right? With a point load is acting at the center. So if it is acting at the center, तो P is defined as the reaction RA की जो value हो जाएगी वो half of P by 2P हो जाएगी. Reaction RB जो हो जाएगा again that is the load P है वो equally distribute हो जाएगा, right? Now understand this one. You know that this is of the y and this one is the x-axis condition. अगर आप इसका ड्रॉ करने की कोशिश करोगे, you will find that the maximum deflection would always occur where the point load is acting, right? So here in this case, load is acting at the midpoint. So this would be your delta max, that is the maximum deflection, right? And at maximum deflection, you find the slope, that is dy by dx value should be 0, right? And at the end points, you will have the theta max, that is the maximum slope, theta max, right? So you know the condition कि at x equals to at x equals to 0 you find the maximum slope. Similarly, at x equals to L by 2 you will find the zero slope. Similarly, at x equals to 0 you find zero deflection, and at x equals to L by 2 you find the maximum deflection, right? Okay, so let's solve this question. So this, I'm just to draw the section, and from this point it is defined as the x-axis, and this section is valid from 0 till L by 2, right? So when we put the value of 0 to L by 2, आपको पता है कि ये अपवर्ड डायरेक्शन में एक रिएक्शन फोर्स लग रहा है जिसको P by 2 है, तो आपका जो मूवमेंट होगा that is mx, which is defined as P by 2 into x, right? So let's solve this equation. We know that ei dy by dx is equals to P by 2x, right? This is the equation we obtained, d square y dx square, right? Let's solve, let's integrate it. So we can define it ei dy by dx is equals to px square by 4 plus c1, right? So can we put x when x is equals to L by 2? The first you can say the criteria. Let's just go divide कर लेते हैं इस part में. At x is equals to L by 2, can we say that dy by dx value, that is slope, is equal to 0? Yes. So based on this value is equals to 0, right? तो p x square by 4 हो जाएगा, यानी कि L by 2 x की वैल्यू L by 2 जाएगी, तो यहाँ पे क्या हो जाएगा, that is 0 is equals to p x की वैल्यू L by 2, यानी कि that is your L square, right? L square by 4, and 4 into 4 is equal to 16 plus c, right? So it means that what the value of C1 here in this case is minus PL square by 16, right? So now I'm going to write this condition. Let's first segregate it. Yeah. So I'm going to write this equation. That equation now is dEI dy by dx is equals to px square by 4 minus PL square by 60, right? Now at x, now on this equation अगर हम बोलते हैं, can we define at x is equals to 0, we will get the theta maximum, right? So put the values of x equals to 0. So the equation is defined as ei theta max is equals to nothing but minus PL square by 16, right? So theta max is defined as PL square by 16 EI. Just take it as a mod because it is in terms of theta, so we can define it in a positive manner, right? So this is the equation of basically the slope, right? Let's solve it. Let's integrate this equation further so we can obtain a deflection equation. So again integrating, we'll get ei into y is equals to, that is p x cube, and 3 into 4 ये हो जाएगी values 12 minus pl square by 16 into x plus c2, right? Now with respect to deflection, just let me know when we put x equals to 0, y equals to 0, right? Right? So at x equals to 0, y equals to 0. तो ये वैल्यू भी 0, ये भी 0, ये भी 0. It means that that the value of C2 is also 0. So we simply define EI into y is equals to px cube by 12 minus PL square by 16. So this is the required equation of deflection, right? We know that at x equals to L by 2, you will get the maximum deflection. So put the value of x is equals to L by 2 in this equation, right? तो आपको इक्वेशन क्या मिलेगी? E I into y is equals to P by 12 into L by 2 Q minus P L square by 16 into L by 2. From this you will get delta max. Delta max is equals to PLQ upon 48 E PLQ upon 48 E. Now I'm just writing a table, and based on the conditions I'm going to write its deflection and its slope, right? That is, you can also consider this is a very important table. And for the gate point of view, you should remember whatever the calculation we have, whatever the cases we have defined. So based on that cases, you need to learn. आपको याद रखना ही है. There is no other alternative, right? So the first one, it is defined as a beam. Then we have a deflection, and then we have a slope values, right? Let's see, right? The first one, which is defined as a cantilever beam with a point load, right? Cantilever with a point load. I believe you all know the deflection values of the cantilever beam with a point load is PLQ by 3EI. Now with respect to slope, it is defined as a PL square upon 2E, right? Case 2. Case 2 is defined as a cantilever beam with UDL. Cantilever beam with UDL. So this value is WL to the power 4 on 8 EI. Similarly, it is defined as WL cube upon 6 EI. Likewise, the third case that I'm going to discuss is your cantilever beam with moment at the free end, right? And its value is defined as ml square by 2EI. We have discussed, right? ml square on 2EI, and it is defined as ml upon EI. Just now we have discussed simply supported beam, right? The third case we have, the fourth one we have discussed the simply supported beam condition, the point load at the center, right? So the value it is defined as a P. Then it is defined as PL cube by 48 EI, and it is defined as a PL square on 16 E, right? The fifth one, simply supported beam with, right. So the first four cases we have discussed, right? The remaining that we are going to discuss, जो कि हम लिखने जा रहे हैं, आप उसको जो है एक बार चेक कर सकते हैं, उसको calculate कर सकते हैं with the help of double integration. You will find this result, right? So the important thing is you need to now learn the things. कि हाँ आपको ये चीज याद रखनी है. L to the power 4 84 e, right? And it is defined as 1 by 24 W L cube upon E. Separate this. This is your beam. Deflection. We have a slope.
सर डाउट है.
Just let me complete it. We'll discuss.
Okay.
ठीक है. So this is your beam condition. This one is your deflection, and this one is your slope. Right. Okay. Now case. Let's define the sixth one. Right. We have defined this. The sixth one, it is defined as your fixed beam. Right. So as per the fixed beam, so two rigid support जो है आपका यहाँ पे लगा हुआ और एक point load है. So based on this criteria, you will find कि आपका जो beam है some will behave like this, right? And on this condition, your maximum slope deflection is defined as 1 by 192 L cube by E I. This would be your maximum deflection. There is no slope here in this case. Now, the seventh one is defined as, again, the fixed beam. Okay. This is the fixed beam, but a UDL is applied on this, right? So again, the condition is defined something like this. The same slope you will also get here in this case, and deflection is defined as 1 by 384 W L to the power 4 upon E I. Right? Now the last case that we are going to see, that is your eighth one, and here in this case we have defined this condition. Right? Suppose in a cantilever beam, a point load P is acting at somewhere a distance from the fixed end, right? So इस conditions को अगर हम समझने की कोशिश करें तो it is something like this. This would be the slope at this particular point, but you need to understand the maximum deflection at this particular point. So this would be your delta max at the free end, right? So the value of delta max, you can say the value of delta max at the free end is a square by 2ei L minus a by 3, right? So in the left side of the conditions up to 1 to 5, you have already seen the deflection, you have already seen the slope. In the right side of the condition, you have not calculated the values, but the values which is already to be given, you have utilized in that particular, right? So these are the things which you need to remember. Later on, you will find every cases you will I'm going to discuss, and one by one आप उसके deflection और slopes को भी कैसे calculate कर रहे हैं ये भी हम calculate. Let's see the next method that we are going to discuss is a method of superpositions. This is again a very interesting method. This is nothing a new one. This is defined as a method of superposition, right? Now let's see this. इसको समझने की कोशिश करते हैं. So suppose you have a cantilever beam with a point load at the center, at the free end. Likewise, you also have a UDL, right? Up, how you are going to see, how you are going to solve this question? As per the double integration method, आप उसके पहले moments को calculate करोगे और उसको आप उसको solve करने की कोशिश करोगे. Yes. Now with the help of this superposition method, what I am going to do is, let's see. We just convert two things. First, मैंने क्या किया? Separate किया एक point load. We just separate a point load, right? Similarly, हमने एक uniformly distributed load को separate किया, right? Now, just tell me one thing. Based on this, आपका एक equation जो है, आपका जो deflection होगा, it behaves something like this, and based on this, you have a deflection जो है, वो define करेगा, it is something like this. Yes or no? Right? आपका क्वेश्चन ये है, आपने उसको कन्वर्ट किया दो डिफरेंट कंडीशंस में. You need a deflection. This is, you can say, the total deflection of the of this two loading conditions, right? So I'm going to write this is the total deflection, that is one, right? Just let me know अगर हम बोलें तो क्या this is the deflection delta 1 of this point load होगा plus deflection delta 2 of this. In the previous slides, we have already defined the deflection with respect to the point load, which value is PLQ by 3EI, right? So can we put this values? PLQ by 3E, right? Similarly, the deflection due to UDL is also to be defined as WL to the power 4 upon 8EI. This is W, right? So the total deflection is defined as delta is PLQ upon 3EI plus WL to the power 4 upon 8E. Understand? So this is basically a very interesting method to find the deflection, and deflection, the total deflection is nothing but a summation of individual deflection, right? Similarly, can we define theta? Yes. The theta is defined as, that is PL square by 2EI plus WLQ upon 6EI. Now these two values with respect to deflections आपको पता है, with respect to slope you have already known. So that theta you can say is defined as a theta 1 plus theta. Let's see this one of the example and how we are going to solve this question. This is one of the easy, you can say, examples, right? So in this we just need to convert. I'm going to convert these into two parts. First, it is defined as a UDL, right? And the second one, which is defined as a point load, right? Which magnitude is W, right? Just let me know one thing. if UDL is there, तो definitely ये आपका जो load है, it will point downward direction, right? And when a load is acting upward, तो आपका ये ऊपर की तरफ shift होगा, right? So its magnitude, it is defined as a small w, that is of kilo Newton per meter, right? And this is W. We have already known कि इसका deflection delta max or delta 1 you can say. What is the value of delta 1 here in this case? For UDL it is defined as WL to the power 4 upon 8 E, right? Now tell me, this is to be addition. तो ये with respect to that, अब आप ये समझो कि with respect to only deflection का value क्या होगा? That is WL cube upon 3ER, right? But it is in opposite direction. तो we are considering, अगर हमने इसको downward directions को अगर suppose करो कि we are considering positive or upward directions को we are considering negative. Here in this case, with respect to that, आपकी values क्या रहेंगे? अब देखो, ये small w के values क्या है? Capital W by L, right? तो capital W by L की value रखेंगे तो L cube हो जाएगा. It is defined as W L cube upon 8 EI minus W L cube upon 3 EI, right? Is it clear to everyone? So can we say that this is defined, the value is delta 1 minus delta 2. When you solve this equation, you will get minus of 5 W L cube upon 24 EI. Is that clear to everyone? Now let's take another example. This is, you can say, a very funny example, right? So let's take another example and how we are going to solve such type of question. Let's see. In this question, we have defined a point load along with the moment. The point load magnitude is P, and the moment magnitude is P dot A, right? Now please solve this.
Sir, what?
Yes, now let's see this condition also. I'm going to solve these questions, right? So again, we are going to separate this into two parts, right? First, we know that this is a point load which is acting in this way. So based on this point load, आपका deflection जो है वो downward direction में होगा, right? Now एक आपका clockwise direction में moment act कर रहा है, and because of this moment, it will definitely go upward, right? So whether it is a negative value or positive value, we'll have to see in that way. We know that the deflection delta 1 is defined as PLQ upon 3EI, right? And deflection delta 2 is defined as ML square upon QEI, right? And here in this case, the values of M is defined, already defined. The M is defined as P into A. Yes. So you put this value delta 1 plus delta 2 and you will get the result. So the final deflection delta is defined as delta 1 plus delta 2, right? So consider downward direction is positive, upward direction is negative. You will get one result, and based on this, you can find the exact deflections. Is that clear to everyone? Class? So these are the very simple and easy examples. इसी के basis पे let's solve one of the gate questions, right?
Sir, sir.
I'm going to solve this question number 4.12. ठीक है? Let's see this condition. जैसे ही आपने यहाँ पे P load apply किया, तो ये load का जो impact है, ये load का impact should definitely occur at this A, right? So what we can do that, जो vertical direction में force है, उसको as it is we just convert it here. We are going to write a P force at point, right? So we have converted. Now you can see that this is at a distance x. तो यहाँ से यहाँ तक की remaining distance कितनी है? L minus x, right? Now L minus x, this is the distance. So P into L minus x at this particular point is giving moment, and that moment is what? Anti-clockwise. So we just convert this moment here as anti-clockwise, right? So we have just converted this case into such kind जिसमें आपका एक पॉइंट लोड एक्ट कर रहा है पी एंड पे और एक मोमेंट एक्ट कर रहा है, ठीक है? अब आप क्या कर रहे हो? अप्लाई सुपरपोजिशन थ्योरम। तो जैसे ही आप यहाँ पे सुपरपोजिशन थ्योरम अप्लाई करते हो तो आपने क्या डिफाइन किया कि एक तो आपका लोड हो गया जो कि पॉइंट पे एक्ट कर रहा है, राइट? दूसरा एक आपका जो मोमेंट है जो कि आपका एक जो कि मोमेंट एक्ट कर रहा है पी एंड पे। जस्ट टेल मी वन थिंग कि इसका मोमेंट का मैग्नीट्यूड क्या होगा? पी एल माइनस एक्स, यही होगा क्या?
Yes,
ठीक
sir.
है। अब इन्होंने क्या बोला कि इस पी लोड की वजह से ये जो बीम होगा डेफिनेटली डाउनवर्ड डायरेक्शन में डिफ्लेक्ट करेगा, बट ये मोमेंट होने की वजह से ये जो बीम है इसका जो डिफ्लेक्शन होगा इट शुड बी अपवर्ड डायरेक्शन वाई एक्सिस, राइट? जस्ट कंसीडर की पॉजिटिव केसेस अगर हमने देखा, इन दैट केस लेट मी नो व्हाट इज द डिफ्लेक्शन एट दिस पॉइंट। यहाँ पे डिफ्लेक्शन कितना होगा इसकी वजह से? आई बिलीव इसका डिफ्लेक्शन होगा पी एल क्यू अपॉन 3 EI, right? I'm going to write it in a very neat manner so that everyone should understand. Because of this, it is defined as a PLQ upon 3EI. Yes or no? Let me know what is the deflection due to this case. The deflection due to this case is M L square upon 2EI. यही होगा ना? यही हमने डिफाइन किया था, M L square upon 2EI, right? अब इस क्वेश्चन को समझो क्या बोला है। What would be the value of x so that the displacement at a is equal to 0? इसका मतलब जो डिफ्लेक्शन यहाँ से हो और जो डिफ्लेक्शन यहाँ पे हो that should be equal, तभी तो ये बीम अपनी पोजीशन पे रिमेन रहेगा। It means what? If I'm going to write ML square upon 2EI, it means what? कि दोनों के जो डिफ्लेक्शन डेल्टा 1 है वो डेल्टा 2 के बराबर होगा, right? Now see this condition. Put the values of m, that is p l minus x. तो ये हो जाएगा p l q upon 3EI is equals to p L minus x into L square upon 2EI. Now this EI cancel out, P cancel out, L square L cube, this one cancel out. तो आपकी इक्वेशन क्या बन गई? यही बनी ना कि 2L is equals to 3L minus 3x, right? Now put this values 3x here, तो ये हो जाएगा 3L minus 2L which is equals to the values of x is equals to L by 3. L by 3 का मतलब हो गया 0.33 L. Is that clear? Now let's discuss one of the another cases which is defined, another method which is defined as your moment area method. Moment area method, right? So what this method says, let's see. Suppose there is a point load on the cantilever beam. A point load is acting at the cantilever beam of this one, right? So in this condition, we can see that this should be the theta value, the maximum theta, right? And if we are going to draw its bending moment diagram, then its bending moment diagram will behave like this, जिसका सेंट्रॉइड यहाँ पे कहीं होगा, सेंट्रॉइड होगा जो कि डिस्टेंस की वैल्यूज होगा, bar, that is 2L by 3, or this is the maximum bending is defined as a PL, right? So let's understand how this method works. In this method, right, the slope is to be calculated is area of bending moment diagram upon flexural rigidity, right? Area of bending moment diagram upon flexural rigidity. Just see. What is the area of this bending moment diagram? Half into length, that is L, into height. So half of PL into L, right, upon E height. So we know that this is equation to be like PL square upon 2EI, and this we have already defined in double integration, right? Now the slope we have calculated. Now we are going to calculate the deflection, right? So the deflection is the same like area of bending moment diagram upon flexural rigidity into x bar. Now what is x bar? x bar वो distance है जो भी हमने यहाँ पे आपको नोट किया, that value is 2L by 3. ठीक है, that is one thing जो किया है. अब important point हमेशा, this is always to remember that जो non zero slope होगा, x का distance आप उधर से calculate करो. मतलब this is the point जहाँ पे non zero slope है, yes or no? The values of x is to be calculated from this point, right? So I am going to write x bar is distance from non-zero slope, right? So just tell me, if I'm going to write this deflection of this cantilever beam, that you have already calculated PL square upon 2EI, so that value is this PL square upon 2EI, right? Into what is the values of x bar? X bar is defined as 2L by 3. So that 2 is cancelled out, and your equation becomes PL cube upon 3E. Yes, this is very easy. This one seems to be very easy, right? So based on this method, let's solve some of the questions. So class, let's see some of the questions in this case, right? So let's see, there is a cantilever beam, right? And there is a moment at the free end. This is defined as M, this is defined as L, right? So based on this conditions criteria, we can see that. So this would be, you can say, the slope of that one. And if I'm going to draw the bending moment diagram, this is your y, this is your x, then it is behave like a rectangle. The bending moment is a rectangle here in this case. This is your bending moment diagram, right? This is of this negative value, and this is magnitude is defined as a minus m, right? So let's find out the slope. So for finding out the values of theta, अगर हम यहाँ पे area of bending moment diagram को देखें, calculate करें, area of bending moment is defined as ml, right? And the theta is defined as, जो कि slope होगा वो क्या हो जाएगा, ml upon ei, right? Likewise, deflection is defined as ml upon ei, right, into x bar. अब here in this case अगर हम define करने की कोशिश करें, this is the L distance, so x bar is defined as L by 2 की values कोई define करेगा, Yes or no? So which can defined as x bar is ml by ei into L by 2. That is, the deflection is defined as your ml square upon 2 ei. Is that clear to everyone? Now, let's take another example and try to solve these questions, right? Suppose in a cantilever beam, a point load P is acting at a distance A, right? This is the point A, this one is the point B, and this one is the point C. So let's see how I'm going to solve such type of a question. So based on the moment area method, let us first draw its bending moment diagram. So when I'm going to draw a bending moment diagram, you can see that if I'm going to draw an x-axis from this point to this point, the values from 0 to B point, you don't find any of the moment. It means that कि from A point to B point तक आपका सिर्फ और सिर्फ एक straight line रहेगा जो कि इस point को behave करेगा, right? Then from B point to C point, अगर आप यहाँ पे cross sections values को consider करो, तो जो भी ये moment आएगा, तो ये linearly behave करेगा with respect to x. So it means what? कि यहाँ से B to C is defined as a moment value. इसका magnitude क्या होगा? P cross A at C point, right? So this is the bending moment diagram of this condition. अब ये है माइनस वैल्यूज. अब इसके सेंटर को अगर आप समझने की कोशिश करो तो दिस इज फ्रॉम फिक्स्ड एंड इट इज डिफाइंड एज a by 3, right? So from this point it is defined as 2a by 3, yes, and from this point this distance is defined as L minus a by 3. Yes, okay. Now we need to understand कि what we are going to find. अगर फर्स्ट हमने यहाँ पे कैलकुलेट किया स्लोप, तो स्लोप एट थीटा बी, राइट? स्लोप एट थीटा बी क्या होगा? थीटा बी के स्लोप को अगर हम समझने की कोशिश करें तो ये स्लोप डिफाइन होगा द वैल्यूज ऑफ थीटा बी, एरिया ऑफ बेंडिंग मोमेंट डायग्राम, राइट? तो एरिया ऑफ दिस बेंडिंग मोमेंट डायग्राम होगा कितना? दैट इज हाफ into this distance. यहाँ से यहाँ तक की distance क्या है? A into height, that is P A upon E. So that value is defined as P A square upon 2 E I. That is the slope at point P. So class, always remember when you are going to draw a slope of this one, you will find this is the slope at this point, right? So this is the slope. तो अगर थीटा बी का स्लोप आप कैलकुलेट करो, ये स्लोप आपने कर्व बनाया, राइट? थीटा बी का जो स्लोप होगा इन दिस केस थीटा ए का भी स्लोप वही होगा, यस? सो द वैल्यूज ऑफ थीटा बी, द स्लोप वी आर टॉकिंग, एंड थीटा ए आर सेम, which is defined as PA square upon 2E. Yes. Now let's understand. This is the deflection. तो फ्रॉम बी पॉइंट यहाँ इतना डिफ्लेक्शन है, लेकिन ए पॉइंट पे डिफ्लेक्शन आपका ज्यादा है, राइट? सो लेट्स अंडरस्टैंड द डिफ्लेक्शन. डेल्टा बी फर्स्ट हम कैलकुलेट करने जा रहे हैं. द डिफ्लेक्शन एट डेल्टा बी, तो आपका एरिया, दिस एरिया, राइट? तो डिफ्लेक्शन एट डेल्टा ए इज डिफाइंड एज एरिया ऑफ बेंडिंग मोमेंट डायग्राम, दैट इज पी ए स्क्वायर अपॉन 2EI इनटू ऑफ एक्स. अब अगर आप यहाँ पे x बार की डिस्टेंस देखोगे तो B पॉइंट से x बार की डिस्टेंस डिफाइंड एज 2a by 3. which is defined as P A cube upon 3 E I. But tell me one thing, क्या deflection at B is same as deflection at A? No. डिफ्लेक्शन बी का और डिफ्लेक्शन ए का अलग है। ए का डिफ्लेक्शन ज्यादा है बी के रिस्पेक्ट में, आप यहाँ पे चीजों को कंपेयर करके भी देख सकते हो। दिस इज योर डिफ्लेक्शन एट ए एंड दिस इज द डिफ्लेक्शन एट, राइट। सो जस्ट लाइक कि आपका स्लोप जो है बी का और ए का सेम है, यू कैन नॉट से दैट द डिफ्लेक्शन एट बी and deflection at A should also be same. So if you want to calculate the deflection at A, तो deflection at A के values को calculate कर लो ना। Simple क्या कहता है, area of bending moment diagram, area of bending moment diagram upon EI into x bar. A है ना एक simple conditions। अब just tell me one thing, from A to B का जो area है वो 0 है, yes। B to C का जो एरिया है वो हम यहाँ पे लिख सकते हैं, दैट इज डिफाइंड एज हाफ द वैल्यूज ऑफ PA into A upon E into x बार। अब x बार क्या है, x बार इज अ डिस्टेंस जो आपको नॉन जीरो स्लोप से कंसीडर करना है। तो यहाँ से यहाँ के डिस्टेंस है कितनी, ये अगर टोटल डिस्टेंस L है, L में से A minus 3 कर दो तो L minus A by 3, it means this is defined as L minus A by 3. So your deflection at A is defined as PA square upon 2EI L minus A by 3. So this is the required deflection at A point. Let's take another example. Let's take another example of this conditions. Another question that I'm going to take. Beam ABC point, cantilever beam, a point moment is at B point is defined as M, right? This is A distance. So if such type of a questions come, so let's see this condition. The first thing is to draw its bending moment. So for drawing the bending moment, just tell me, हमने यहाँ पे एक sections लिया होगा तो from A to B there is no bending moment, right? And तो यहाँ से आपका एक पॉइंट बना A to B, A to B, जैसे ही B पे आया आपको एक मोमेंट मिला, मोमेंट का मैग्नीट्यूड हुआ M और ये आपका डिफाइन होगा। तो दिस इज योर मोमेंट, यस, माइनस वैल्यूज एंड इट्स मैग्नीट्यूड इज M. दिस वन इज योर x axis, राइट? ओके, अब ये वैल्यूज कहाँ लाई करेगा, सेंट्रॉइड इसका A by 2 डिस्टेंस। It means what? The distance from this point to this point is L minus A by 2, right? Okay. Whatever the slope, if I write theta A, that should be equals to theta B. And the theta B की values क्या होगा, ये area into that is M into A upon E, right? Likewise, let us understand the deflection at A, right? Sorry, let's first find out B deflection. This point का deflection क्या होगा, area हमने calculate किया, that is MA upon EI into A by 2, right? So that is the area. So its equation to be written as MA square upon 2EI. Likewise, what is the deflection at B? So from A to B there should not be any area. The area B to C point को ही cover करेगा, which is defined as MA upon E into I, right? अब x bar की distance, तो x bar की distance यहाँ से आप calculate कर रहे हो ना, that is defined as L minus A by, So you can see that with the help of this moment area method, you can easily solve its deflections values as well as its slope. In this question, we have defined some of the conditions, right? इस UDL load की वजह से there must be some slope at this particular point. We'll just draw a slope at this one, and because of that slope, ये values यहाँ पे extend कर जाएगी, right? So one thing we know that this is the deflection delta B, right? So this is the deflection delta B at this particular point. So we are considering up to this point, it is defined as delta B, and there is a deflection at A extra, जो कि added values है. We have defined delta dash, right? So can we say that the deflection at A point is nothing but deflection at B plus deflection delta dash, right? So this should be the behavior, you can say. This should be the behavior of your slope at this particular point, right? Okay. We know that the value, अगर आप ये इस चीज़ों को सोचे होते हैं कि आपका सिर्फ बीम जो है कैंटिलीवर बीम सिर्फ इतना ही कंडीशंस को डिफाइन कर रहा होता, राइट? Up to this point, you know the value of theta, right? You have already calculated in that particular fashion कि अगर आपके पास एक कैंटिलीवर बीम है, राइट? आपके पास एक कैंटिलीवर बीम है जिसमें आपको यूडीएल दिया हुआ है, तो उसका डिफ्लेक्शन वैल्यू कितना है WL⁴ ATI, और उसका स्लोप क्या है WL³/6EI, राइट? तो जस्ट इमेजिन कि आपके पास इसी कंडीशंस को आप मान लीजिए, तो थीटा बी की वैल्यू क्या होगी, वो हम लिख सकते हैं क्या WAQ/6EI. Similarly, we have defined delta B, that is your WA⁴/8E. So these two values we already know with the help of double integration method or with the help of any method, right? अगर आपको ये चीज क्लियर है तो कैन वी डिफाइन दिस पॉइंट. अगर हम इस ट्राइंगल को समझने की कोशिश करें, दिस ट्राइंगल, so what is the length of this one? That is defined as L-A, right? This is the angle theta B, right? So अब आपका इसी पर्टिकुलर पॉइंट को अगर आप एनालाइज करो, कैन यू राइट दिस, ये अगर आपका वैल्यू जो होगा tan theta B can be written as delta dash minus L by A, right? So we have defined कि delta dash की वैल्यूज क्या हो जाएगी, that is defined as L minus A tan theta, right? So consider, अगर हमने यहाँ पे लिया कि theta B जो deflection is very small, तो आपका जो tan theta B है delta dash की जो वैल्यूज है can be written as into theta B. This is simply a jugaad method, always remember, right? So if this is to be written, so we have defined theta B, so which is defined as WAQ/6EI into L minus A, right? So the deflection, you can say delta A is defined as delta B plus delta dash, right? So delta B can be written as, delta B you have already defined, that is WA⁴/8EI plus L minus A WAQ/6EI. This is the deflection at A point. This is a very short method, convenient to understand, and it is simply how जुगाड़ method है जो कि आप चीजों को easily चीजों को calculate कर सकते हैं. That is one. Second thing is, right, जो स्लोप है थीटा बी का, दैट इज द स्लोप ऑफ थीटा ए, दैट पॉइंट इज ऑलवेज रिमेंबर। इसका मतलब आपको जो वैल्यूज रह जाएगा डब्ल्यू ए अपॉन 0.6 ई आई दैट विल रिमेन